everybody, it's Math at Home here with our fourth lesson. Today is going to be a workbook session. We're going to be covering page 73 and 74, which is going to be about doubling and halving the numbers. Okay, so please open up your workbooks and let's get it started. First thing first, we will start from page 73. Question number 6. Arrange all of the digits so that all the calculations have the same answers. Use what you know about factors to help you. Okay, so basically, we start from A. So first thing first, remember that 24, if we want to break it down into its factors, it can be written as 4 times 6. So this is going to be pretty much useful for us. Okay, so I start 24 times 3 times 5 is going to give us 360. Now, if I break down 24 into 4 times 6, and I time that 6 by 5 here in our multiplication, it's going to give me 30. So what is going to be remaining is 3 and 4. Therefore, I will have 3 times 4, 360. Now, what I need to do is to turn 45 somehow into 360. So I could write as 45 times 2, 90. So 9 times what equals 36? Absolutely 4. So times 4, 360. Question number 7. The numbers in this path double as they go along. Fill in the missing numbers. So as numbers, we will have 400, which is the double of 200. Then double 400 is 800, 1600, 3200. Now, in order to double 3200, leave the zeros, double 32, 64, add the 2 zeros in front, 6400 and 12800. Now we have 230. Once we want to go leftwards, we need to half it. So half of 200 is 100 and half of 30 is 15. So it'll be 115, then 57.7, then 57.5. Now we could start from 230 and go rightwards. It is going to give us 460. Double 400 is 800. Double 60 is 120. Altogether is 920. 1840. And last but not least, 3680. About 10.6. Once you go leftwards, you need to half it. So half 10 is 5, half 0.6 is 0.3. So altogether is going to make 5.3. Then we could double it. Double 10.6, double 10 is 20, double 0.6 is 1.2. So altogether is going to make 21.2, 42.4, 84.8, and 169.6. Now part D is going to start with 2.25, double 2 is 4, double 0.25 is 0.50. So it'll give us 4.50 or 4.5, 9, 18, and 36. Question number 8. Recipe for 6 people uses 450 grams of pasta and 90 grams of cheese. How many grams of pasta and cheese are needed for a recipe for 3 people? Okay, since we know 3 is half of 6, so all we need to do is to half the values of pasta and cheese. So we had 450 grams of pasta. So 400 half it, 200. 50 half it, 25. Together, 225. About 90, we half it, and we're going to have 45 grams. A cafe uses 720 grams of cheese for the same recipe. How many people did they make the recipe for? I'll give you some minutes to think about this question. Okay, Basically, in order to find the number of the people, we need to know how many grams of cheese do we use for one person. Cheese is used for 3 people. So obviously for one person, we need to divide it by 3. So 45 divided by 3 will leave us 15. Now we know for one person we need 15 grams of cheese. We have 720 grams of cheese all together. What we need to do in order to find the number of people, we need to divide 720 by 15. So 720 by 15 is going to give us 48 people. So the answer is 48 people. Question number 3. Here are 5 single-digit numbers: 3, 4, 5, 7, and 8. A. Choose 3 digits and arrange them in a division calculation so that your answer has a remainder. Now, turn the remainder into a fraction. Alright, so I will choose numbers 53, 5 and 3, and let's divide it by 4. Because I know that I will have 13 4s in 53 if I make the long division. 13 times 4 is going to leave me 52. So 1 is going to be the remainder. Now, how am I going to write the 1 as a fraction here? Very nice. It'll be 1 over, because it's divided by 4, 4. Part B. Choose 3 digits to find the calculation that gives you the largest remainder, and another 3 for the calculation that gives you the smallest remainder. Record the calculations and answers you make. I'll give you a couple of minutes to think about any possible variations of the numbers that will give us the largest and the smallest remainder. Okay, now it's time to answer the questions. After trying out many combinations of the numbers, you will figure out that with the cards in the example above, 34 divided by 5 will give the largest remainder of 4 that could be turned into the fraction 4 over 5. Now about the smallest remainder, with the cards in the example above, again, 53 divided by 4 will give the smallest remainder of 4 that could be turned into the fraction 1 over 4. Now about the smallest remainder, with the cards in the example above, 53 divided by 4 will give the smallest remainder of 1 that could be turned into fraction 1 over 4. Alright, let's switch into page 74. Question 10. Afia picks 3-digit cards to make a division calculation with a remainder. She turns her remainder into the fraction 3 over 8. So the remainder actually is 3. Which 3 digits cards could she use? Use an example calculation to help explain your answer. In order to find the number, we're going to use the clues given in the question. So look at the remainder. It is a fraction. The denominator is 8. It means the number is divided by 8. And the remainder is 3. This gives me the idea of whatever the number is should be 3 more than a multiple of 8. Because the number is divided by 8 and 3 has left as a remainder. So, as an answer, I could say the calculation will need to involve a number that is 3 more than a multiple of 8. So it can be, for example, 35 divided by 8. Since the multiple of 8 right before 35 is 32, and it has 3 extra, so it's going to give me 4 as an answer and remainder of 3, which I could write 3 over 8. So my number could be 35 divided by 8. You could actually choose any multiple, add 3 over it, and could be your final answer. For example, let's say 5 times 8 is 40. Add 3, 43. So if you basically divide 43 by 8, your final answer is going to be 3 over 8. Question number 11. What are the answers to these calculations? Remember to look at the brackets first. Work down the columns. Okay, so basically this part is about the brackets and the priority of brackets. I'll give you 2 minutes to find the answers for the first and the second column, please. Okay, let's get it started. 9 times 5 times 6 inside the bracket equals. So first you need to go through the bracket. 5 times 6 is 30. 30 times 9, 270. Now the second one, 9 times 5 first, which is going to make 45, times 6, which is going to make 270 again. 6 times 9 is going to make 54 times 5, 270. And 6 times 9 times 5 will make 270. Now you might wonder, despite the fact that we have brackets here, all the answers are the same. So what is the magic? The reason is all the functions here are including multiplication. So you know 2 times 3 equals 3 times 2. In multiplication, direction doesn't matter. It means you could do however you want. So basically, having brackets here is going to be nonsense, as you witnessed. But what if one of the functions are addition? So for example, second column, 9 times 5 plus 6. So 5 plus 6 is going to be 11 times 9, 99. Now, 9 times 5 inside the bracket plus 6. 9 times 5 is going to be 45 plus 6 is going to make 51. So apparently our answers are going to be different this time because we have multiplication and addition, and bracket prioritize the functions between them. 6 plus 9 is going to make 15 times 5, 75. And 6 times 9 plus 5. 9 plus 5 is 14, plus 6 is going to leave us 84. So, how can you explain this to Afia? Afia says, that is strange. I think that all the answers in the first column are the same, but they are not all the same in the second column. Why? Well, Afia, I need to say, the answer is, for example, all the calculations in the first column only involve multiplication, and it doesn't matter which order they are carried out in. The calculation in the second column includes multiplication and addition, and they cannot be carried out in any order. You have to do the brackets first. Question number 12. Use brackets to help you keep track of the calculation in these problems. I give you a couple of minutes to do part A and B in question 12. Okay, let's get started about question 12. Pencils come in packs of 25. Orlando buys 5 packs. He gives 10 pencils to Afia. How many pencils does he have left? So obviously what we need to do here, to calculate first the number of the total pencils before he gave it to Afia, then subtract the 10 pencils that he gave out. In order to do all in one calculation, we need brackets. So I will basically say 25 times 5 minus 10, but using the brackets. Therefore, our answer is going to be inside the bracket 25 times 5 minus 10. It's going to be 125 minus 10, which is going to leave 115. Part B. It costs a cafe $2.40 to make 6 cakes. They sell each cake at 25 cents more than it costs to make them. How much do they sell each cake for? Again, the same story. We need to find the price of each cake, then add 25 cents in order to understand how much do they sell it for. So here, we will use the brackets also. So we will say 2.4 divided by 6 in order to find the price of one individual, and then add 25 cents over. So it'll make 65 cents. So they are selling each cake for 65 cents. This was our workbook session today. Thanks for your cooperation. Stay tuned in for our upcoming videos. Take good care and bye bye.